Hello everyone. Have another CalcPlot3D video for you. This time we are going to talk about line integrals. So basically we're going to look at how we can travel along space curves or even just parametrically defined curves in 2D that pass through a vector field. Okay, so we're going to have two pieces that we add here. So I'm actually going to start with my vector field. So I can go down, add my vector field. We're going to start with a 3D version, see that that is kind of tough, but you can maybe get some intuition from it and then see that the 2D version is actually quite good. So we're going to do X, Y, Z, just kind of everything moving out from the origin. If you remember from the last video, it helps to have more vectors along the z-axis so that we actually see three-dimensional stuff, and then maybe have a few fewer vectors and maybe of shorter length. So I'm going to divide these all by 6 in this case. And then I'm going to also need a space curve. So I'm going to just go ahead and use the default here. So this is going to be a helix, right? I've got cosine and sine, so it's going to be circular in the xy coordinates, and then my height is going to increase linearly with this 0.1t, so I'll click it. So I find this to be too many colors kind of going on, especially because my space curve kind of like blends in. So I do like to keep my vector field in different colors, but I do like to use a constant primary color for my space curve. And I'm just going to make it a little bit longer. So rather than -10 to -10 or to 10, I'm going to do -20 to 20. And then let's just kind of see what happens here when I drag this back and click animate. So I'm going to move along my space curve through time. And notice number of steps is 500. This means that I'm going pretty slowly along my curve. Not necessarily a bad thing. Depends on what you're looking for and everything. But you can see us moving through this vector field. Now, when you have a fixed perspective like we have here, I don't think that that's very helpful in seeing whether we're going kind of like with the flow, against the flow, etc. Also, things are really busy here. So when we were looking back at like velocity and acceleration and stuff, it was helpful to have these vectors, right? This blue one is my position vector, the black one is tangent to my curve and is my velocity vector, and then I have my acceleration vector pointing back in toward the z-axis here. But I actually want to get rid of those because they're not really helping me in this case. It's not really telling me whether I'm working with the flow or against the flow, and thus is just kind of redundant. So I'm going to click off the vector equations. Those disappear. I'm going to get rid of my green vector, the acceleration. I'm going to get rid of my black one, the velocity vector. And I'm actually going to get rid of the blue one, my trace vector. I do, however, want to keep my trace point because I do want to see where I'm at along the curve. Okay. So when we start moving along, right? One, if you do want to go faster, I could do this. Whoa, that's the opposite of faster. I could do like 100 steps instead of 500 steps, and you're going to notice a lot faster than when I did 500, right? I am going to go to 500 though, and bring this down. So if you wanted to, you could try to kind of keep along with it and see like, oh, it looks like I'm kind of going against the flow as I move around, and you can kind of zoom in, rotate in this circle to see kind of what's happening as you go around. It makes it a little easier to deal with, but especially with more complicated vector fields or a more complicated curve where, right, like this one, I'm just literally going around in a circle, so I can just click like the left arrow key over and over and it rotates correctly for me. But if you have something that's nasty, you're going to be following it around and doing all sorts of weird stuff, or maybe you have to use the click and drag. Either way, it's probably going to get rather challenging. So it's doable, but like I said, challenging. On the other hand, if you are restricting view to 2D, then I have the vector field just x, y, right? So again, everything is emanating out from the origin, and I'm just moving around my circle coming from the cosine t sine t. In this case, it's actually really easy to see what is going on. So here, we're going to see that the line integral would be 0 because we're going to be perpendicular. Notice like all of these little vector field guys are perpendicular to the circle or orthogonal to the circle. So as we go around, we're basically always moving orthogonal to the flow and thus doing no work. If this isn't enough arrows to tell that that's true, we can go down here, just click on your vector field and just add more vectors, right? So in this case, all that matters is the x and y axis because we don't see any of the z axis stuff. So let's do like 13. And I can even maybe make these a little longer. That way you see more things touching. So again, you can kind of see orthogonal, orthogonal, going to be orthogonal. If you wanted to, I can even make it longer. You can just see all of these vectors that hit your red circle are doing so at a 90-degree angle, right? And so when you go back here and animate, you can see that just wherever you are, you're going to be orthogonal to your vector field and thus doing no work. So I find that very helpful and honestly not too bad in 2D. So let's look at one more example that's maybe a little more complicated. So here I haven't really changed my vector field at all. However, I am going to make these a bit shorter again because it's rough. But what I did was change from cosine and sine to t and t squared. So we're actually just looking along y equals x squared. And you can kind of see what's going to happen as I move forward. So here I'm starting from -20. So maybe I want to start on the picture. So let's go t equals -2 to 2, and let's just do like 100 steps. So in this case, we can see we're going against the flow, a little less against, now we're orthogonal, and then now we're going with the flow, and as the magnitudes increase, we're going more with the flow, right? And it's going to be stronger. And so you can use things like this as long as you have your parametric equation, and as long as you have your vector field. The 2D ones, you're basically always going to be able to see what's going on with whether you're against or with the flow. And the 3D one, you can probably get there. It's just going to take a little bit more work and a lot of shifting around your perspective to follow your path along the curve. Okay, so hopefully you find that helpful. And that's all I've got for you. So thank you for watching.